In this video, we're going to take a look at some examples of graphing radical functions. So for number one, we have y equals the square root of x minus 2. And it asks, how is this function's graph different from the parent function? So if we take a look back at our transformations, the value that has changed is the one right here, x minus h, the part underneath the radical sign. And that makes it go to the left or the right. So notice if it's a positive h, it goes to the left. And if it's minus h, it goes to the right. So in example 1, we have minus 2, so it actually goes to the right 2 units. So that's how it is different from our parent function. And we say that it shifts to the right 2. So then let's pick out some values that would be easy for us to graph. So I'm going to pick 2, 6, 11, and 18 so that when I plug them in, they'll come out as nice numbers for my graph. So I'm going to plug them into the square root of x minus 2. So that means I have the square root of 2 minus 2, the square root of 6 minus 2, the square root of 11 minus 2, and the square root of 18 minus 2. And then that would give me the square root of 2 minus 2 is just the square root of 0, so that's equal to 0. The square root of 6 minus 2 is the square root of 4, so that equals 2. The square root of 11 minus 2 is the square root of 9, so that's equal to 3. And then the square root of 18 minus 2, which would be the square root of 16, and then that would be 4. And so then we could plot the points 2, 0. So I'm going to come over here to my graph and plot for a minute. So 2, 0, 6 will go with 2. So 2, 4, 6. And then the rest of them are off of my graph. But as long as I have those two and I know the general shape of my graph kind of looks like that, then I get a decent sketch. So notice this graph compared to our parent function up here shifted to the right 2 units. And then we just need to state what the domain and range are. So the domain for this graph would be that x is greater than or equal to 2 because it starts right there instead of at 0 this time. And then the range still starts at y equals 0 and then goes up from there. So we'd say y is greater than or equal to 0. Okay, so let's take a look at example 2. So 2 is similar to example 1, except for it has x plus 3. So it says, how is this function's graph different from the parent function? This one would shift to the left instead of the right. So left 3 units. And then let's pick out some points that would help us to graph this easily. So I've already decided that -3, 1, 6, and 13 would help me to have some easy numbers to fill in. And you'll see why when we fill them in just a second. So we're going to put them into the square root of x plus 3. So that means I would have the square root of -3 plus 3, the square root of 1 plus 3, the square root of 6 plus 3, and last but not least, the square root of 13 plus 3. So then I have the square root of 0, which is 0, the square root of 4, which is 2, the square root of 9, which would be 3, and the square root of 16, which would be 4. So then I could quickly plot these points on my graph. So -3, 0. I have 1, 2, and 6, 3. So 1, 2, 3, 4, 5, 6, 3. And then I could sketch my graph going to the right. So then the domain and the range for this graph, notice it looks like our parent function, but it has shifted to the left 3 units. So now the domain is x is greater than or equal to -3. And then the range is still starting with y equals 0, and then it goes up. So y would just be greater than or equal to 0. All right, let's look at one more example on this video, and then we'll do another video of some more examples, just so this video is not too long. So example 3 has the square root of x plus 2. Notice this plus 2 is not underneath the radical sign. So this plus 2 makes our graph shift up 2 units. So if we look back at our parent function up here, it's the k value. So k makes it have a vertical shift up if it's positive and down if it's negative. So it shifted up 2. Let's pick out some points that make it easy for us to fill in. So I'm going to pick 0, 4, 9, and 16. And then let's plug those into the square root of x plus 2. So that'll be the square root of 0 plus 2, the square root of 4 plus 2, the square root of 9 plus 2, and the square root of 16 plus 2. So the square root of 0 plus 2 would just be 2. The square root of 4 is 2, plus 2 would be 4. The square root of 9 would be 3, and 3 plus 2 would be 5. And then the square root of 16 is 4, and 4 plus 2 would be 6. So then let's plot those points. So we have 0, 2. We have 4, 4, and then the rest of them don't fit on our graph, but we get a good idea that this graph is just simply shifted up 2 units from where our parent function was. And then the domain, so notice our x value starts at 0 and then goes up from there. So x would be greater than or equal to 0. But then the y value starts at positive 2 and goes up. So y would be greater than or equal to 2.